Speaking about what's happening now, our next speaker, I'm super excited to invite up. He's called Samay Lakhani, and he's probably the same age as a lot of you guys in this room, same age as me too, all the way from New York, and he has got loads to share. Welcome, Samay.
Thank you so much.
I'm excited.
So thank you so much, Tilly. Thanks, Stephen, for the amazing presentation. Can we get my presentation up? OK, perfect. So hey, everyone. My name is Samay Lakhani. I'm a researcher and engineer at Columbia University. And today I'm going to talk about a question that's intrigued me for about the last 2 years. Is what if you could control the world around you, get all the work done that you want done without even moving a single muscle? All the problems that you have, just imagine it done, and it's done. So last year, I was here talking about connecting our minds to computers to get things done. These are called brain-computer interfaces, and since then, we've made tremendous progress that's blown our expectations past our wildest predictions. And I'm super excited to talk about what that means for us as a human race. We're standing at a tipping point where lots of these innovations aren't just science fiction or stuck in some research lab somewhere. They're coming to everyday users like you or me. And so today I'm going to talk about what the basics of these brain-computer interfaces are, how they work, how they're evolving, and what the future of this looks like for all of you guys. So before we go any further, how many of you guys know what a brain-computer interface is or have heard of it? OK. Some of you do, some of you don't. And yeah, so that's why I'm here. A brain-computer interface, at its core, is a connection between the computer and the mind. It's using it to control the world around you. And let's take a moment to appreciate how much our brain does for us every day. When you listen to me speak, billions of neurons are firing, hopefully understanding what I'm saying. Your thoughts, your ideas, your emotions, your feelings, they almost all happen over here. And you express those thoughts and ideas through your body. My hands, my voice are all expressing it through my brain. But what if we could directly access the signal that's coming from the brain and use it to control technology? And I think that's going to be one of the most interesting innovations for the next 10, 20, 30, and beyond years. So we're controlling the world around us, but how exactly do we do that? So let me go over the kinds of ways to collect the data directly from our brains. There's a few kinds of interfaces, but I'll go over the top 3. So the first one is the EEG. And this is basically just reading the electrical activity from your scalp, from your brain on the outside. It's non-invasive, which means you don't have to drill anything into your skull to get the signal out of there. Second is the fMRI. You've probably seen this in a hospital or a medical center. They're pretty commonplace. They're huge machines that use spinning magnets to get a full picture of what's going on inside of your brain at every single layer. They give so much data on all of the signals, what you're thinking about as you look at a picture or do some kind of task using your brain. We can track the activity through that. And lastly, these are kind of the scarier ones, but they work really well. These are the neural implants. These neural implants wire directly into the top of your skull or the base of your skull, and they have a full direct connection of high-quality data of all of the neurons firing inside of your brain. These are really cool. So, OK, we're collecting data from your brain, but looking at this signal, so here's a picture of me, maybe not that great of a picture of wearing an EEG on top of my head with the legendary Ashley Kim. I was working in a lab at Columbia University last year using these EEG signals. And we used it to control these modular robots. If you've ever seen Big Hero 6, that's essentially what we were trying to do. Yeah, again, they do not look that great. But we collected the data, and this is what the data ends up looking like. So on the top, those little squiggly lines, that's electrical data from the EEG. And there's usually about 16 different channels, but the technical details don't matter right now. I could talk offline about that, because there's a lot to that. And the other brain scan image that you see, that is an fMRI scan. And so we have a lot of this data. How on earth do we read any of the thoughts here? Right? So we can't do this as humans. So what we can do is we can pass it on to an AI decoder that's able to read it like a puzzle and decode all of the complex signals going on inside of your brain. And we get the thought. So here's like a quick example of what that paradigm means. So scientists at the University of Singapore did a little bit of an experiment where they decode the images, thoughts, and dreams that you were thinking of, which sounds insane, and it is. There is a patient lying down in an fMRI looking at a picture of a swan. The data is ingested, recorded, and we take that fMRI pattern and we use AI to decode that pattern. And the computer fully reconstructed the image the person was thinking of based on only the fMRI data. We are literally reading people's minds. And this was like last year. So the question is, where are we today? We've made more progress in the last year than we have ever before in brain-computer interfaces because we're accelerating. What does the future of these implants look like? Or maybe not even implants. There's a lot of questions to ask. So I'm going to go over some of the biggest advancements we've had over the last year and what that means for the future. So first and foremost, one of the most monumental developments was the Neuralink N1 chip implant. So this is one that gets wired directly into your skull to compute super high quality data. And there was a patient with a severed spinal cord. He had almost no control over his body other than his face, but the rest of his body, he couldn't move. And this restored his ability to interact with the world around him. He could use a computer to send messages, play games, do whatever he wanted. So let's play that video right here.
Hey, I'm Nolan. 7 years ago, I dislocated my C4, C5 while swimming in a lake. There were a lot of things to adjust to. Some things I would have never guessed would be difficult became very difficult.
It's Nolan's biggest dream right now to become independent. I hope that this study not only helps him to do that, but it also helps technology to advance in quadriplegics.
I'm really excited to be a part of this Neuralink project. I want to help out people down the road as much as I can.
I mean, when I first actually moved the cursor with my mind, it blew my mind for like a whole day. And to be helping, to be able to be useful in some way, it completely changed how I live.
So I think this is just truly amazing. I mean, in the future, of course, it starts off with health and giving back people their independence and their autonomy. But I think in the future, people are going to take these up voluntarily. Like, I'm somewhat of a lazy person myself, and if I was able to control the world around me just by thinking, moving from using my hands and keyboards to just thinking about what I want done, I mean, that would be amazing. The next example is something a little bit more fun. And this is something that I would also really like to use. It's more about the voluntary uptake, and that's gaming. So without using invasive implants, we're able to figure out how to use games and control those games using just our thoughts. So here's a video of somebody playing the video game Elden Ring. It's a super difficult game, and they're able to control their character with lots of precision.
Is it records, or the software that comes with this particular headset can record what your brain looks like this. This is me when I'm talking to you. This is me when I'm focusing on attacking. You see how different it is. For attacking, I'm imagining pushing something heavy really forward. For healing, I'm imagining something falling on top of my face. I'm more like pulling it towards me. It takes hours of training to do this, so it's kind of like an on-off switch. Is it there or is it not? And if it's there, up past a certain threshold, then it presses the key through the command and the node red and the coding and stuff. You're supposed to be perfectly still, otherwise there's so much noise. That's one of the limitations of EEG. There's a lot of noise, just from everything. You have to keep adjusting them, you have to make sure they're super conductive and in the right place as well. But at a certain point, it's not necessarily a limitation of the device, but a limitation of how much we know about the brain. I mean, there's always going to be that, regardless of how amazing your equipment is.
So this is also a pretty cool example. And this game requires lots of skill and precision. I tried to play this game myself with a normal keyboard and mouse, and I just kept on dying and dying and dying. But it's amazing that with just your thoughts, you're able to get that level of precision. I think she actually beat the game. So for the voluntary usage of this, I said maybe 10 to 20 years minimum before people actually start deciding they want this in their brains, right? It's definitely going to take a lot of social upheaval, lots of convincing, because not everybody wants a robot with needles going into their skull. And it's good that they're apprehensive about that. So the next example is going back to medicine and healthcare and restoring some kind of function back to people. Again, this is where the BCIs start. They start with medical reasons, things that will really help people who need it, and then eventually it goes to voluntary. So a company called Science Corp, headed by one of the former Neuralink executives, Max Hodak, they developed a model called Prima, where they put a retinal implant in somebody's eye, and they basically restore vision to people, which, again, just amazing. So here's some pictures from their demo. So the retinal implant goes inside of the person's eye, and it has a camera feed. It processes that camera feed down to come up with the image you see on the right, which it says the ER, and it's in black and white. They do that so it takes less data to transmit to the patient, and you can see the improvements that they've made in that person's eyesight. If you've ever been to the doctor, this is one of those charts where you read it and you see how well your vision is. They had a mean improvement of 4.6 lines, which is roughly maybe a 2 to 3 times increase on average. And the best improvement was maybe a 4 times increase in the level of their eyesight, which I think is super helpful. So the question is, what happens next? Why am I not talking to you all telepathically and using a brain-computer interface right now? And the reason is because there's about 2 huge limitations, I'd say. First is the social, consequences of having technology embedded inside of you. And the second is simply the hardware. So let's go talk about the future of how this evolves. First, BCIs are scary. I was super excited last year about having a BCI in my brain, but then I got a little bit older, a little bit mature, and then I realized maybe I don't want to be the guinea pig. Maybe we have to wait and see before I want to drill something metal into my skull, although it would have some amazing benefits. Here are some funny memes that people have put together. I'll give you a second to look at that. I mean, people are apprehensive. People are skeptical about this, and that's fair, which is why I think it'll take maybe 10 to 20 years for people to really be okay with that fact, that they're going to have something, they're going to have implants inside of them. Next is hardware. So I put together these graphs, and people are telling me I shouldn't put these graphs in. And raise your hand if you could tell me if you know what any of these mean. Because if you do, you're probably lying. These mean nothing. I was working on a project where we tried to decode EEGs to thoughts, and we just got noise, just garbage data on garbage data. The issue with these implants and EEGs is that they're not consistent at all. If I put on an EEG and I'm moving around versus not moving around, or if I'm in one environment or another, the EEG data can fluctuate significantly, which means that it's not always going to work. One day it will work, the other day it won't. And so these graphs are basically showing we could find very, very little correlations in our own data. So a lot of the data that you actually see in research studies can be cherry-picked. So once we overcome these limitations, what's the world going to look like? I think we're going to be able to interact with technology in a way that redefines what it means to be human. These are all examples of amazing technologies. We have Claude, we have OpenAI, we have Google, we have robotics that will be able to control, directly receive and transmit information to and from. We can control a robot with just thinking about where we want that robot to go, almost like a second body. Or maybe we'll be able to download the information that we want from the internet. And I think that's what the future of it could realistically look like. And after that, as a little bit more of an interesting idea is, when I speak to you, there's lots of words that I'm saying, and maybe I'm not coming across clearly or I'm not fully expressing my experiences to you. What if we could transmit every minute detail of the human experience and emotion to another person, two people from opposite sides of the world who speak entirely different languages? What if they could communicate at a level that no two people have ever communicated at all, like really communicated at any point in time? I think this is really the power of directly accessing the brain. So I'm 19 years old. I'm probably not much older than many of you. And I started building these projects when I was pretty young. And so a lot of people ask me how I start. Since this technology is 10, 20, 30 years in the future, that means we're the ones building this technology. It's not somebody else. It's us. And I want to explain how possible it is to do these things. And the first thing to do is know that you can learn anything. Every single day, there's a new advancement that comes out. And that puts you, students, ahead of everyone else. I have met PhDs working on the same project for the last 5 years, but in a field of technology where everything changes day by day, you have the opportunity to learn something new, especially as students. When you have the free time to just explore and you find out the newest innovation, it's just so easy to rebuild it or experiment or play with it. It's always a level playing field because everything is new. And I think because of that, because of the accessibility of coding and even using ChatGPT, if you don't know how to code, you can build these things too and learn them because it's all on the internet. The second thing is to have fun. If you're not having fun, just don't do it. Do what you like to do and do nothing else. You have to express yourself to the fullest version of yourself. And if you don't like building technology, that's fine. What do you like building? Do you not like building at all? Maybe you like something different. If you're not having fun with it, you're probably not going to go very far with it. I remember I had a lot of fun building technology stuff, and that's why I kind of chose this field. So one time, I was 16 years old. I was really bored. It was over the pandemic. And I found something called GANs, Generative Adversarial Networks. And these were like the early image generators. So I took like a file of tens of thousands of album covers, and I threw it into the program, and then it generated like an animated album cover representing all of the album covers from the last 50 years. And it was just fun. It was funny and cool to see all these random weird generations get created. I also had a lot of fun 3D printing, and I didn't do it for anything serious. I didn't do it for any research projects or any awards or accolades. I just did it because it was fun. I mean, I wanted to play Flight Simulator on my computer. I didn't want to buy the controls, so I just 3D printed it, and you can see that controller in the middle that does the flight simulators. I needed a charger for my laptop, so I just had some fun designing stuff. Another one, this one is a pretty good example of how having fun can just get you to good places, is I started learning something called computer vision, which is AI used with images and video and things like that. So I made like a teddy bear classifier because, just for fun. I thought it was kind of funny. I made a bean classifier, and somebody actually heard about my work, and they're like, we have a similar problem for our company, which is a motorcycle company, Revel. And lots of people weren't wearing their helmets, and unfortunately, they were getting injured or killed because they weren't wearing their helmets while they were on the motorcycles. So I applied that exact same kind of process to help detect the helmets. And I actually got a job from that. So it was fun, and it worked. The last thing is, I've said it once, and I'm going to say it again, is fuck around and find out. Literally just take risks. Failure means nothing unless it's catastrophic. When I was going into one of my first labs, I applied to maybe like 60 labs, and almost every single one of them said no. I got one maybe. The professor who said maybe didn't even want to talk to me. I just kept showing week by week by week at his lab, sitting in a corner, doing the project, even if he didn't even approve of the project. me and my partner just kept on going, and we persevered long enough that he actually gave us an A in the class, even though we weren't even signed up for it. And they signed us up at the end for it because we did a pretty good job. And that's all I have to say. You are all more capable than you think you are. And really anything you want is accessible to you if you want it bad enough. And I'm super excited to see what the future looks like. I'm super excited to build a future with you all. And thank you so much. I'm so happy to be here.